Hello guys, myself Vivek Pandey, and I guess you all know me. And who don't know me, like for them, my name. And so guys, I'm just starting a new playlist, and this is all about problem solving. So now let's understand what exactly the problem and how we are going to solve it in a different ways. Yeah. So till now you were seeing that I was giving the recorded sessions. I was posting recorded sessions on my YouTube channel, but yes, those I got an opportunity from an institute to record the session. So I thought like instead of keeping with me, why don't I help others also? So that will be helpful for even others, not only my students, the students whom I have not taken any classes. For them also it will be helpful. That's the reason I posted. I know those are lengthy videos, but this video is not going to be that lengthy. It's below 45 minutes. Yeah, so every week or twice in a week, I'm going to help you out with one problem solving. So today we are going to see one very basic problem. Let's understand without wasting further much time. Now let's start the session. So now the session is all about, let's see the question. Write a program to check if a given number is even or odd. Odd. Now guys, you can say that, sir, this is very small or very basic question you have picked. Yes, I know this is very basic, but we can do it in a different ways. So now let's see what are the different ways we have. First way, we already know that what is the first way is of what, like if a number is there, 9 is there, now I need to do what, the reminder. Whenever I'm dividing it with the 2, the reminder should be what, 0. If it is 0, then we can say it is even number. So let me take here a 10. 10 I'm dividing by 2, then it should leave the reminder what, 0. Then we call this number as a 10 as a even number. Yes, this is common thing. And if it is 9 divided by 2, what is the reminder for this? The reminder will be what, just 1 it will be, because 2 4 ja 8 and 1 is a reminder. So reminder is 1, and we can say that this is odd number. Yeah. So how we can do this? Simple it is. So how we can do, we have one operator, that is percentile operator or mod operator, we can call it as. So for example, this is division, but mod operator we can use here. So like 9 or a 10 mod 2. If it is equalizing to 0, then we can say that this is my even number. Yes, this is my even number. Yeah, good. Now we are going to see it in the program, and we see that whether this one is working or not. We already know. Let's start. So here I'm taking what, number is equal to, now I'm taking what, input. In this input I need to give the number, right? enter a number enter number. But you all already, I guess, if you know, this input will take only string values, but I'm entering an integer, so I need to do typecast here. So int of input. Yes. Now I'm asking a number from a user to enter. Once if the user is entering, then I need to give the condition here. If number percentile to equal to, if it is 0, then here print, what we need to use here, like even, else it is odd. So print odd. Fine. Now let's see whether it's working or not. Then I need to execute this. Yeah, it is not visible to all of you, so I'm just killing this, and once again I'm running this, executing. And then for example, if I'm giving 10 here, it is giving me even. Very good, it's working, guys. Now if I'm giving here 1, it means what, I need to change it, right? 1 will be given on always by what, odd. So odd here, and here it is even. So you need to understand that if this condition is true, then only this print statement will be getting executed. Now let's see. I will be giving odd here. Odd means just 5. 5 is odd. So it is working perfectly all right. Yes. So we already know about this. So let's okay. Let's it's done. Now what I will be doing is second part. So second way by using what? Bitwise. So in order to use the bitwise, let me tell you the conversion. First we need to understand by using what? Bitwise operators. Bitwise operators also we can do, like what are the bitwise operators we do have, and what we are going to use here, and or XOR, and then uh, left shift and then right shift. Okay, these are the operators which we are going to use in order to find whether a given number is even or odd. Now let's see here. Now before this we need to understand how to convert a number into binary. So I guess you all know how to convert it, but still I just wanted to help you out how we can convert it into binary. So there is a small formula. You can just take it as a formula, and just you can remember that, because it is binary means 2, right? Base is 2. So what we can have, like 2 to the power of 0, it is always 1. Again 2 to the power of 1, it is 2. 2 to the power of 2, it is 4. Yes. Yeah. Now again here 2 to the power of 3, it is 8. Again here it is 16. Now again 16 to ja 32, 32. So like this keeps on going on. 64, like this. Yeah. So now, for example, if I wanted to convert 5, I wanted to convert 5 into binary, then what I need to do, I need to check what are the numbers I need to add. So what are the numbers I'm adding? 4 plus 1. So is my 64 is participating in this? No. Then 0. 32? No. 0. 16 is also not participating to make 5 0. And then 0. And 8 is also not participating. 0. And 4 is participating? Yes. 2 is participating? No. 0. 1 is participating? Yes. 4 plus 1. Now this becomes what? My 5. So what is my 5? 5 is, for 5 we got, this is the number we got for 5. Yes. Yeah. So 5 I got. Now in the same way, how to get for 1? This is for 5. I got for 5. And how about for 1? Is this is participating? 64? No. 0. 32? No. 0. Here it is 0, 0. Everything is 0, right? This is also 0. This is participating. So I'm writing it as 1. So this is 1. Now here, what I need to do here is, I'm not taking consideration into all these bits up to 4 bits. So 1, 2, 3, 4, 4 bits. Okay. So from here I will draw one line here. Okay. Now let's see what I need to use here. Yes, I'm going to use here AND operation, and operation, and let's see what is happening with the and what is the characteristics of and. If at least one, now here it is 0 and here it is 0. If at least one is 0, everything will be 0 here. So what is the meaning of this? 0 0, it will be 0. Here at least one is 0, so this is also 0. Now here 0 0, it is also 0. Here it is 0. Here it is both are 1, so it is 1. So what is the meaning of this? This is my binary. I need to convert it into what? Decimal. So by converting decimal, it will be 1. The value is 1. So what I can say, that whenever we are converting, whenever we are doing 5 and 1, 5 is odd, we are getting always 1. Now in the same way, let's try for a 6. 6 and 1. How much we are going to get? Let's see. Yes. So now this here itself, I will convert this 5 into 6. So one thing is clear, guys. One thing is clear. What is clear here? Now, as it is 1, 5 and 1, it is giving me what? See here, 5. Yeah. So I'm just removing this part. 5, 5 and 1. It is giving me, how much it is giving me? Just 1 it is giving. Yes, it is giving me just 1. Yeah. And it is giving me 1. Fine. And now we need to check that whether even number 6 and 1. What is this it is giving me? Yes, based on that we'll be writing our conditions. So now I will change this as 6. Let me do it 6. 1 will be same. So in order to make a 6, what I need to do? 6. So I'm just writing here itself 6. Okay. So in order to do the 6, what are the numbers are participating here? Okay, let me remove this one. Yeah. So 6 here, and then yeah, 6 means 4 plus 2, right? 4 plus 2. It means here this is 4 and this is 2. So here I'm removing this part, and here it will be 0, and then this part is 1. So this is what? 1 1 4 plus 2. So these two are participating to make 6. So 1 and 1, and here it is 0. So what I'm going to perform again AND operation with a 6. 6 is an even number, so here it is 6. Good. Now let's see here what is happening. 1 and 0, how much it is? 0, because and characteristic is what? We it should be always both are true, then only it will be true for the resultant, or else it is false. Here also it is false, here also it is false. So overall we are getting what? 0. When we are getting 0, when we are doing with a even number, we are getting what? 0. So what is my intention here is, whenever, so I'm just removing this, and we are done with and. Yes. So whenever I'm performing AND operation by 5 and 1, means odd number. So this is what n I'm taking here, also I'm taking as n. So this is for what? When I'm getting 1 here, this is for odd number. Okay. So yes, this is for odd number. So here n can be any general number. So it is not only 5 or 6, it is general number. So it is for odd, and this is for even. Okay, even. Now this is done. Now let's see it in this, and let's try to execute this. So number is already there. What I need to do here, I need to use what? AND operation, and it is giving 1, right? Then it means it is odd. So let's see. And here what I need to use? 1, with the 1. So let's execute this. Enter a number. I'm using 5. It is giving me odd. Good. Now once again, let me run this code. I'm entering 99. It is giving me odd. Good. Now if I execute by taking as any even number 10, it is even, giving even. Good. So it means what? It is working perfectly. If I'm giving here 0, what will happen? If I'm giving here 0 means what? This condition is for even, so it should be even here, even, and here it should be odd, else part is odd. Fine. Now let's execute this. Yes, now I'm giving 100. 100 is even number. Yeah, again I'm executing this. 1 not 2, that's even. So it's perfectly working, guys. So it is working perfectly. Yes, 1 and 2 is done. This is 1 and this is 2. Good. Now once this is done, now let's see. With and we are done. We are done with and. Now let's try with a or operation. So now I will take the same 6, and let's go with this 4 digits here, and we are going to use or now. Or is indicated in this way. Now here or means what? At least if it is 1 is true, all will be true. Here both are 0 0, so it is 0. Here at least 1 is true, so here it is 1. Here also at least 1 is true, here it is 1. Here it is at least 1 is true. Yes, this is in this at least 1 is true, so here it is 1. So how much? With or operator. Yes, with or operator, how much it is? So this is all 3 ones. 3 ones means what? 1 plus 2 plus 3 plus 4 is 7. So total 7 I got. So what is the meaning of this? The meaning is whenever we are going with a 6, 6 or 1, it is giving me 7. 7. It means what? 7. Yes, this is what it is giving me. Now, if I'm taking odd number 5, so for 5, what I need to do here? Here it should be 1, and here it should be 0. So 0. Now, let's check what is happening with this. So it is both are 0. So 0. Here it is 1 and 0. It means 1, because characteristics of a or, what it says, at least 1 is true, everything will be true. So here again it is 0, here again it is both are true, means it is 1. So it is giving me what? Same resultant, it is 5. So what is the meaning of this? 5 or 1, it is giving me same, 5 only. Yeah, so here what we can write here, general stuff. Third one is n or 1, it gives same n, then it is what? Odd. Odd. And the fourth one is n or 1, it is giving what? N plus 1, then it is even. Even. Now let's see the practically. Let's see practically whether it's happening or not. So here I'm just removing this, replacing this and with or, and if it is same number, then it should be, if let's see for even. Even means what? Number plus 1. So let's try to execute this. Enter a number 10. Even, it is giving me even. Good, it's working, guys. So let's execute once again. I'm taking here 11. 11 is giving me odd because this condition is not satisfied. Yes, that's the reason it is going and executing this else part. Okay, now one more thing. If the number is same, means what? It is for odd, so I need to use here odd. I need to mention odd, and here it is even. Even. Now let's see here. Yeah, now 7. Yes, it's perfectly working. So I guess we have understood about this or also. Or is done. Now one more thing is remaining. Now let's see how we can do that. Now this part is done. Yes. Now we have one more thing that is called or, like XOR we have. This is called what? XOR. XOR. Now this is done. Now in this XOR, what is happening, guys? So now first what I will do is 5 XOR, or it is already 6 is there, right? So 6 XOR 1. With the even number, what is happening, and with the odd number, what is happening, that's we need to check. XOR 1. Yeah, these two resultant we need to check, and then we'll generalize the formula in the condition. Now here both are, first we need to understand what is this XOR means. XOR means when both are opposite, then it will be true. If both are same means false. Now let's understand here this way. Here from 8th bit, from this 4th bit, both are 0. 0 means what? Both are same. Then here it is both are different, then it is 1. True. Here also both are same, then it is 0. Here it is both are different. No, both are same here. So same means both are same, right? 1 1 same side, same. 0 0 same. So here it is only this part is different. So what is the value for this? 100. 100 means what? 1. This both are 0. So it is 4. 4 is the answer. So 4 for what? For 6 we got 4. This is the 4. 4 is the answer. So what is the meaning of this? Let's see here. This is 1 0. See here. What I made is, the mistake is 6, right? 6 means it should be, yes, it should be 1. And here it is 0. Yeah, now it becomes 6. Earlier it was not 6. So it should not be 4. That's all. Yeah. So see here, 1 0, it is 1, 1 0, 1, 1 0, 1. Yes, not 4. So what is the meaning of this? We need to always check that whether 6 is we have positioned it in correct manner or not. 4, 1, 1. This is 4 plus 2. It is 6, right? That is the reason here at the 1 is not contributing. So it is 0. Now we need to check 1 and 0 both are different. 1. Then it is resultant is true. True is denoted by 1. Again 1 0, this is true. This is 0 and 1, that is also both are different side. So we are getting how much? We are getting 7. So it means what? Even number, whenever we are doing with the even number, it is giving us more, like 7 we are getting. It is for even number. Even number. Now let's go with the odd number ones. Now here what I need to do is I need to make it as 5. 5 means 101, because 2 is not contributing for 5. Yeah, this is done. Now I'm removing 0 0, both are same. Again this is both are different, so here it is 1. This is both are same, 0, both are same again, 0. So here we are getting what? 4. So it means we are getting 4 here, and when we are getting 4 it means it is less. So what we can write here, it is for odd. So for odd, yeah, let's see the general formula for this. Fifth one is n XOR 1. If it is giving n plus 1, then it is even. And the sixth one is if it is giving n XOR 1 and it is giving us less, n minus 1, then it is odd. So now let's execute this once. After executing only we'll come to know. So I'm getting even for this, for 6. Yes, here only I need to replace the symbol XOR, and for odd it is right. Odd means number minus 1. Now let's execute this. Enter a number 7. It is odd. Perfect. Perfectly working. Now again, this time I'm entering some even number. It is giving me even. Perfect. Now what I need to do is I need to change something in this. Changing something means what? This condition is given for the odd itself. Now for even I need to write. So even means plus 1. And here also I need to change this even. And here it is odd. Odd. Now let's execute this. 10. 10 is an even number. Good. Now 13, odd number. So here the condition I have given is for even. Okay, whenever I'm giving the condition for even, the first print in the if condition, the if print, it is inside the if block, that should be even. Yeah. So we have learned these 3 things. What are these 3 things, guys? Yes. With the help of these 3, we got all 6 combinations. Yes. So with the and, I think one and I already have written here. What first one? Yes. All 6 combinations. One is this is for even. Here it is for 1. Okay, it's already there. Yeah. So this is the combinations, guys. These are the combinations. Good. Let's proceed further. Now we are done with this. Now here we also have shift operators. Shift operators. What is the meaning of this shift operators? In the bitwise operators, we have this is right shift and again left shift operator. Now let's understand what is the meaning of this and what it does. So if I have this 4, I need to convert it into what? Binary. So it is conversion is 1 0 0. So 1 2 zeros. Now here what I'm doing is I'm just giving a right shift by 1. By 1 right shift means what? This 1 will occupy this place and this 0 will occupy this place and this 0 will be out. So this will become 1 0, because this 1 is replacing this 0, right? This 0 and this 0 is coming towards. So it means what? All the bits are moving towards right side. right shift. After right shift, I got this. Okay. Now, after this, what I need to do, whatever I have 1 and 0, on this I need to apply left shift by 1. So what I'm applying is left. So all the bits I'm moving towards left side. So if I move towards the left side, what will happen? This one. So here earlier it was nothing. Nothing means what? It is 0. You can assume that it is 0. So this 1 will be replacing here 0. Here it will be 1. Again this one will be here. And in the place of this 0, another 0 will be added. So finally what will be the answer? 1, 0, 0. Yes. So what is the meaning of this? Guys, so what we can say that we can simply say that even by using what left shift operators, we can solve our question. Which question? Even, finding even and odd. Yes. So now let's see how we can do that. So how we can write the notation? The notation is, for example, if it is n or if it is 4, we have already seen here. It is like 2. The if I'm converting it into decimal, it is 2. And from this 2, if I'm making the shift towards left side, then it becomes again 4. So how the condition will be, like for example, n is there. First what we have done, right shift by 1, then again left shift by 1, and it should be equal to the same number. Okay, now let's execute it here. Yeah, so in the number, first what we need to do, right shift, and then again right shift by 1, then again left shift by 1, and then we are equalizing to the number. So here double equal to, now it means what? It is coming to its position, so it is even. If it is coming to its position, means it is even. If it is not, in some situation, like if it is 5, for 5 we are doing, we'll be getting the same thing, same value. Yes, let's see once. So for 5, how we can do for 5? Let's see here. So to convert 5, how we can do for 5? 1, 0, 1. On this, what I need to apply? I need to apply right shift by 1. So when I'm applying right shift by 1, what happens? This one will be coming here and this 0 will be coming here. It means what? It will be giving me how much? 1. Here and same thing. Now when I'm applying on this, this is what? 2, right? So when I'm applying this on this, this is 2. Now I'm applying left shift by 1. So what it will become? It will be 4. So it is not equalizing. In this case, what is happening is 5 right shift by 1, again left shift by 1 is not equal to 5. This is for odd. Okay. So now let's see whether it is working or not. This is for even. Enter a number 20. Perfect. It is working all good. Now once again, now here 17 is not 17 is not satisfied this condition. If condition, that's the reason else is printing. That's it, guys. So that's about what this shift operators we are done. So good. Now after this, we also have one more way. There are many ways, but what are the ways? I know, I'm just informing you. I'm just teaching you all those. Now one more thing we have is, just you can notice here, if I'm converting this 3 into binary, so what will be the value here? 0, 1 and 1. Yes, and 5. For 5, for example, if you're treating this as 1, 2, 3, means last number is 1 always for all the odd numbers. For 5 is what? 1, 0 and 1. Again for 7, also it is 1, 1, 1. So for all odd numbers, odd numbers, odd numbers when we are converting it into binary. All odd number or odd number binary binary last digit is 1. Okay, so when all the binary, when we are converting the odd numbers into binary, then the last digit is 1. Yes, now let's see the even for 4. For 2, for 2 how much? 1 and then 0, and for 4 it is 1 0 0. For 6 it is 1 1 and then 0. So it means what? For all the even number, binary last digit is 0. So based on this we can write the condition. Yes, so what are the things we need to do first? First step is convert a number, convert a number into binary. Okay, second one, save save the last digit of the binary. Okay, we are saving the last digit of a binary. Yes, yes. After this, what is happening, guys? Now we are saving it, and then we are using what? Condition. We are using what? Condition. Condition. Now let's see. Yeah, now we'll see here what is happening. So first we have taken the number. Now in order to convert, I need to convert. I'm just going to convert. So I'm just writing here convert. Convert into what? Binary. Okay, binary. I'm converting into binary. So I'm writing, taking what? Binary. How we can convert the number into binary? Bin of. We have one inbuilt function that is called bin of number. It will directly convert it into binary. Once after it is getting converted, now what I need to do? I need to take the last value, right? Last value. How to take the last value in the binary? Whatever we have, the indexing we need to use. The indexing means we also can use, we don't know exactly, right, how right side or left side. So directly it is last means what? We have two indexings, like backward and also forward. We are going to use what? Last digit, right? So -1. Yes, now after this we need to one more thing we need to understand. Whenever we are using bin of, it is always, the type is always in a string format. String. Yeah, so now what we need to do here is we are going to apply the condition. The condition is if the last value, last value is equal to string of 0 0. If it is 0, then if it is 0 means what I said, print even, right? So even, and else what? Print odd. That's it. So it is even. Why it is even? Because the last digit, like 4, 4 8, all the even numbers, last digit is 0. That's the reason. Now let's execute this and check whether it is giving us right results or not. Yeah, now I wanted to enter 30. 30 is even, perfectly working. Now here it is 45. It is odd because it is not satisfying the condition here. Yeah, now you may get a doubt, right, like why we have taken this. So it means, to clear your doubt, now I will print here, print the type type of what? Type of last value. Okay, so now I'm going to print this last value, and I'm just going to comment all this. This I will comment here. So it is asking me the number. I'm just giving the number here, 112. So 12 I given. In this 12, so str means what it is? The last value. It is what? String. That is the reason I'm using what? String. Now if I'm not using the string, let's see what happens here. I'm just commenting this with the hash. Let's check. Okay, at this time I already given, but let me close this one. Yes, I'm just removing this part. I'm just using only the number, integer number, and then I'm executing it. I'm giving 10 or I'm giving 5. 5 is what? Odd. Yeah, 5 is odd. Let's check with the even ones. 10. See here. This is the wrong result it is giving me. 10 is the 10 is even? 10 is even, but here it is giving odd. What is the meaning of this? So 10, when I entered the 10, 10 means 1010, right? 1010. And is it find any zero? It means what? It is saying that integer 0. So integer 0 is not available there. It is a string. So that's the reason it is going for the wrong. It is not for everything, it is giving me the odd. So else is getting executed if condition is not getting executed, if it is not in a string. So that is the reason we have to write it in the string, because we have seen the type of this also. So that's it, guys. So I guess you have understood. So what is the conclusion of all this today's session? The conclusion of today's session. The conclusion is we learn to check if a given number is even or not, even or odd. How many? By using what? By using first one is percentile, second one is and, third one is or, and then fourth one is XOR, and fifth one is left shift and right shift. Sixth one is the last digit of a binary binary number of a of an binary of a given number, means with the last digit also we are comparing. So all these things we have learned, 6 ways we have learned to check whether a given number is even or odd. So I hope if you find this video valuable, or you learned something new, learned if you have learned, then please do share it with others. Share. And what else you can do to show your love towards this? You can do all those, like subscribe, like, everything. So this is what that's it for today. And again, in the next video I will be solving another problem. Okay, so these things will be doing in Python only. Yeah, till then, thank you, guys. Thank you.
The meeting has ended. Thank you for joining. Goodbye.